All right, we're going to do the last 2 pages together because it's really only 3 problems. It's just the third problem wasn't fitting on the page the way I wanted it to, so we're going to do it this way. Number 9 says, the amount, Y, of a 24 milligram dose of caffeine remaining in the bloodstream after X hours decreases by 20%. That should actually say per hour. So I will make sure that I point that out to you guys when you get your notes. Write an equation to represent the exponential growth or decay of this system. So, first of all, we have to figure out, is this growth or decay? Well, it says the dose remaining decreases. So decreases means it's going to be decay, which means we're going to use the minus for this equation. But we need to find A and R to begin with. So our initial amount is 24 milligrams. Our rate is 20%. But remember, we need to change that to a decimal in order to put it into the equation. So my first version of this will be y equals 24 times 1 minus 0.20 to the power of x. Okay, plugging in A and R to this formula. Then we do the simple math inside of here. 1 minus 0.20, y equals 24 times 0.8 to the power of x. This is the equation that represents this situation. Okay, use this model to predict the amount of caffeine that will remain in the bloodstream after 4 hours. Okay, hours is one of our variables. Time is going to be x, so x equals 4. Again, we are going to plug it into the calculator. 24 times 0.8 to the power of x. We're going to look for x equals 4 and y equals 9.83. Now, caffeine, since it is a chemical, we can use decimals. We don't want to round it too much. I would say 9.83 is plenty though. So we'll say y equals 9.83, and the original question was in milligrams. I'm going to put milligrams. Approximately when will half of the caffeine remain in the bloodstream? Well, our initial dose was 24, so we want y to be approximately 12, which would be half of that. So I'm going to look on the y column for what the closest thing to 12 is, and it looks like that's it. After 3 hours, it's approximately half. See, that's 12.28. That's closer to half than 9 or 15, so be approximately 3 hours. Okay. Number 10. The table below shows the number of electric car charging stations in a medium-sized city for the first few years after their production. Write an equation to represent the exponential function of this system. And it says, hint, the equation is y equals a times b to the power of x. Now remember, a is the initial amount. And since we're using b here, b is going to be the multiplier. That's how the function grows from one term to the next. So the initial amount is going to be where x equals 0, which means our initial amount is going to be 2. Okay, it starts off with 2 charging stations. Then you're going to figure out how it changes from one term to the next. So from 2 to 6 times 3, 6 to 18 times 3, 18 to 54 is times 3, 54 to 162 is times 3. That one's maybe a calculator question. What's the difference between these two? But hopefully from 2 to 6 and 6 to 18 you can at least do by memory. So this is times 3, times 3, times 3, times 3. So my multiplier is going to be 3. Then we're going to use those two numbers to plug into this formula here. So it becomes 2 times 3 to the power of x. Describes the growth of charging stations. Predict the number of charging stations after 10 years. Well, years is my x column. So when x equals 10, what is y? Again, we have a calculator just for this purpose. 2 times 3 to the power of x. We're going to go find when x equals 10. It is 118,000 and some. Okay? So, y equals 118,098 charging stations. Okay? If the town has approximately 120,000 students, how many years will it take for each student to have their own charging station? Well, I would say 118 is approximately 120,000. If we want to look here, you'll see the next one goes way beyond that. Okay, so we don't need to wait 11 years. It would be approximately 10 years. And that's one of the things you need to be careful with. is not overestimating because that's pretty darn close. All right. One last question. This is the graph question. It says Asim accepted a position at a job that guarantees annual raises based on a fixed formula. His initial salary is $20,000 per year, and his salary increases exponentially by 2.5% each year, as shown in the graph at right. The first question is not a graph question. It asks you to write an equation to describe this exponential situation. First of all, is it growth or decay? Well, he's getting a raise every year, so it's going to be a growth situation. We need to then find out what are A and R, which are both in the question. A is the initial amount. His initial salary is $20,000, so that's $20,000. R is the rate at 2.5. Okay, we want to make sure that we get this correct though. So remember, to change from decimal, or so from a percentage to a decimal, you are going to take that percentage, look at that so you can see it, and divide by 100, which becomes 0.025. So be very careful with that. And we're going to plug it into the formula here because it's growth. We're going to use the plus. Y equals 20,000 times 1 plus 0.025 to the power of x. Simplify what's inside of there. So it becomes y equals 20,000 times 1.025 to the power of x. Whenever you're adding something to 1, it's much easier than subtracting. Letter B says, approximately how long will it take for Asim's salary to reach $30,000? Well, there's a couple of ways you can do that. I'm going to use the graph first. So at $30,000, here's $30,000, and that lands right around 16 years. Okay, right around 16 years. So about 16 years. If you remember yesterday, though, once we put the equation together, we can find out exactly where that happens. So we're going to go ahead and plug that in just to check. 20,000, that's the right number of zeros, 1.025 to the power of x. Okay, so we're going to look for $30,000 in the y column. So here's, I was starting at 5 from the last question. If you look over here, the numbers are still growing. So if I keep going, 16 years is 29,690. 17 years is 30,432. So it's actually between 16 and 17 years, but that still pretty much matches our answer. So about 16 years is fine. If you put between 16 and 17 years, that's also fine. Those are both acceptable answers. Okay. Letter C asks, approximately what will Asim's salary be in 8 years? So years is at the bottom, we go to 8, draw our line up till it meets the line, and we are going to go ahead and take a look at where that meets the y-axis. On my graph, it looks like approximately 25,000. That's an acceptable answer. Again, since we have the calculator, we can find the exact number. So 8 years is 24,368. If you look at the next one, though, it's even closer. 9 years would be 24,977. So in this case, I would take either one of those answers. About 25,000 is okay. This is okay. So you can see that there's a little bit of fudging room there. Just don't make your answer super crazy. If you make it, for example, 30,000, that's not right. If you make it 20,000, that's not right. You need to be close. Okay, that's all I'm asking for. And that is your review. It took us all of about 15 minutes. I expect it won't take you much longer. So good luck, and please, please, please let me know that you watch this, because it does take me some time to do, but I really think it could be helpful if it was used a lot more than it is. So go for it.